We've talked about vertical asymptotes, so now we're going to talk about horizontal asymptotes. Horizontal asymptotes are based off of the degrees of the numerator and the denominator. So this chart is kind of confusing with its wording, how it's using like m's and n's and all this stuff. So read that, it kind of makes sense, but we're going to go through the example so it makes like a lot more sense. Basically, there's three cases. So if the degree of the numerator is less than the degree of the denominator, then you have y equals 0 as your horizontal asymptote, which is the x-axis. If the degree of the numerator is greater than the degree of the denominator, then you don't have any horizontal asymptote. And if the degrees are the same, you look at the coefficients and you find the ratio. So it's always going to be one of these three things. So if we look at A, okay, we want to see what the degree of the numerator is and the degree of the denominator. Now remember, degree is like the highest exponent that you have. So in A, I have negative 2x to the first power, and on the bottom I have x to the first power. Since the degrees are both 1, I'm going to look at the coefficients. So in front of the x to the first on the top, I have a negative 2, and in front of the x to the first on the bottom, I have nothing, which is really a 1. So negative 2 over 1 is going to be negative 2. So I have a horizontal asymptote at y equals negative 2. On B, if we look at the degrees, the numerator is x to the first, the denominator is x to the second. So since the top is less than the bottom, this horizontal asymptote is y equals 0. Okay, so it doesn't matter what the coefficients are or anything this time. It's just if the degree of the top is less than the bottom, it's just y equals 0. And then if the degree on the top, like in C, is greater than the degree in the bottom, then you have no horizontal asymptote. So in C, we have x squared, so we have a degree of 2 on the top, and on the bottom we have x to the first, so a degree of 1. Since 2 is greater than 1, this horizontal asymptote is none. Okay, so just take some getting used to. As long as you know those three rules, what you're looking for, this is pretty simple. Okay, so it's either going to be none, 0, or the ratio of the coefficients. The other thing that we need to find is the x and the y intercepts. So to find the x-intercepts, you're setting y to 0. So think about if you have an x-intercept, it's where it's crossing the x-axis, so the y value will always be 0. A shortcut to actually find this is to just set the numerator equal to 0 and solve it. Okay, because you're setting the whole function to 0, so you only care about the bottom, because if it's the whole fraction is equal to 0, if you multiply by the denominator to get rid of it, it's still going to be the numerator equals 0. So take the numerator, set it to 0, and solve it. To find the y-intercept, okay, that's when x is 0. So the y-intercept is where it's crossing the y-axis, where x is always 0. So just plug in 0 for x into the simplified function and solve for y. So for a shortcut, since you're plugging in 0 for all the x's, they're all going to be 0. So any term that doesn't have a 0, so any of your constant terms, you're going to look at the constant term in the numerator and the denominator and just find their ratio, as long as it's in standard form. And intercepts should always be written as points. So it's always x comma y. So if it's an x-intercept, it's going to be an x comma 0. If it's a y-intercept, it's going to be a 0 comma y. Okay, so let's look at this example. So here, we want to find the x and the y-intercepts. So to find the x-intercepts, we're just going to set the numerator equal to 0. So for the x-intercepts, we're going to take the numerator, which is x minus 1, and set it equal to 0. So we get 1. And we want to write it as a point. So my x-intercept is 1, 0. For the y-intercept, we want to plug in 0 for all of the x's. So it's going to be 0 minus 1 over 0 squared minus 4 times 0 plus 4. Since everything that has a 0 that was once an x is just going to be 0, you're looking at your constant terms. So in the initial problem, the constant terms are at the end. So it's just going to be negative 1/4. And again, we want to write it as a point. So x is 0 in this case, y is negative 1/4.